just pop back to the agenda. Okay. I'd like to begin by acknowledging the traditional owners and custodians of the lands on which we all meet today. And for me, that's the Kaurna people of the Adelaide Plains. I pay my respects to their elders past and present, as well as emerging leaders. Please feel free to put where you're coming from in the chat. So this is, I'd like to just highlight that this is a knowledge sharing policy event. It's certainly apolitical, although policy recommendations will be discussed, although not necessarily promoted, but it certainly is an apolitical discussion. The webinar's being recorded. We've got 3 expert speakers, Katharine Hall, Dr. Yasser Arafat and Laura Jones, myself as co-host and Craig Froome as co-host. The order today will be that I'll provide a little bit of background, high-level background and introduction, introduce Craig, and then we'll introduce the speakers one at a time. They'll be giving their discussions or their presentations, and then we'll follow with a panel discussion at open floor Q&A. Craig Froome will highlight some key points, next steps and closing. I would just ask everybody, unless you're asking a question, just to put yourself on mute. Please use the chat function and we'll just get straight into it. So I'll just hop out of that one. Okay. So thank you all very much for being here today. It's an absolute delight to have you all here. I feel really lucky that we've got these 3 expert panelists here today. We have quite an interesting and niche group of people, I would say, here today. We've got people from the Tasmanian government, ACT government, the federal government, DQ. We've got 5 universities that had registered, so University of Tasmania, ANU, University of Queensland, University of Sussex registered, as well as University of Southern Queensland. We've got 5 niche or emerging consultancies in the energy space that are joining us today, so that's absolutely wonderful. And some OEMs, including SMA and Tesla and Pico Energy. We also had Smart Energy Council and Clean Energy Council sign up today too. So thank you so much to all of you for attending today. So I'll just introduce myself before I pass to Craig. I've been in the energy sector for about 15 years. I've worked in government, in energy policy and regulation team in Tasmania. Have worked in consultancy. I'm now a principal with a niche consultancy called Energy Policy Research. I did my PhD on a virtual power plant based in Tasmania as a case study looking at energy policy and prosumers, and have also worked in the private sector. So I've worked for an OEM, and my passion and my interest is energy policy and equity, prosumers and consumers, and for consumers to be at the heart of the energy system transition. We hear a lot about that, but it's the implementation obviously can be quite more of a difficult thing in some ways. So that's about it from me, other than to say that I'm also with the University of Tasmania as a postdoc research associate. So I've got a long-standing relationship with the University of Tasmania, who values having that interaction between industry and research. So I think that's one of the wonderful things about having this gathering today, is that there is such a cross-section of industry and academia and government, which is really, really wonderful. So I'm just going to pass over to Craig now and put myself on mute, and lovely to meet you all. Thank you for being here.
Okay, just a brief introduction on myself. I'm currently the Queensland Chair and the National Director of the Australian Institute of Energy, an adjunct associate professor at the University of Southern Queensland, and involved in the consulting firm Energetic Effects. My background is primarily in the renewable energy area, where I worked at the University of Queensland for a number of years in the Global Change Institute, managing their renewable energy projects. So welcome to everybody today. And I'll hand back to Varian to introduce our speakers. So yeah, look forward to an interesting webinar.
All right. I'd just like to kick off with Katharine Hall, and I've just got a little prepared notes on Katharine. So Katharine is the CEO of the Association for the Battery Recycling Industry. It's an organisation that's a national organisation. They've got when you have a look at their pre-reading materials that have gone through, you'll see some links to their website and some of the work and reports they've done, and they've recently provided recommendations and a briefing to the environment ministers coming up to next month's environment ministerial meeting, which will have a focus on battery recycling. So this is actually quite a timely discussion in some ways. Katharine has previously been a Deputy Secretary in the New South Wales Department of Planning, and her topic that she's going to be speaking on today is producer responsibility and a systems approach to battery stewardship. So she's going to provide an overview of the battery recycling industry with an eye to the December Environment Ministerial meeting. Now, before Katharine just starts, one of the reasons why this is such an important thing to talk about, and yes, of course, you know, it's timely because of the ministerial meeting coming up next month. But we've got 4 million houses in Australia now that have got solar PV. Only between 1% and 2% of those houses have penetration of batteries. Battery storage is one of the keys to the energy system transition, which is consumer-led. So it is a really, really important topic. So thank you so much, Katharine.
Thanks, Varian, for that kind introduction. That topic sounds much grander when you say it than I think to what I'll be talking about. So I'll just give you a quick overview of ABRI. ABRI has over 60 members across the battery value chain. They recycle all battery chemistries and all applications. The main recycling sector is lead acid. So think about your car starter battery, which is actually a really great circular economy product because a very high percentage of that battery can actually be recovered. And I think quite often you'll probably find that your new battery has a high recycled content. The big growth area is lithium batteries, energy storage being one component of that. But there's lithium batteries penetrating all sorts of spaces like forklifts, marine use, recreational camping, caravans, a whole range of activities. They're hugely topical at the moment for a whole range of reasons, both in their role to support the energy transition, but as you'll see, particularly some battery categories, there's some product quality and fire risk issues. It's really important when you think about batteries to understand it's not one size fits all, and there's a number of different market segments. Clearly your EV and energy storage batteries, very different construction and quality proposition to some of the stories we've been hearing more recently about causes of house fires. There's a heap of really useful information on various fire websites around household battery management, which I'd strongly encourage everyone to take a look at and read. I'm just going to share just one slide today just to talk you through a bit about the battery supply chain. Hold on, no, just share. Has that come up, Virian? Sorry, I can't see with the screen on. I'm hoping that.
Yeah,
no,
yes.
it is up.
It is
up,
there.
but it's
Right.
neat.
So-
You could maximise it maybe. I'll make it a bit bigger.
It's just,
It's just
Behind.
screen. Yeah, it's your
It's
screen, not a
PowerPoint.
slideshow.
yeah, put it on slideshow.
Yeah, you've shared this so yeah, the presentation was just showing the PowerPoint window.
What always drives me nuts about Teams. Just for a
These
moment.
things never go smoothly.
Oh, cancel. Let's try this. I'm just going to do it the cheats way, which won't be ideal, but happy to share this with everyone afterwards. It's not working either. I should have put it in PDF beforehand. It's usually better. Share. Is that better? I know it's still the full thing.
Yep, you can definitely see it and read it.
Okay. So the important thing to remember about battery recycling is there's several parts to it's not just one activity. I'm going to first talk this through discussing lead acid batteries because it's kind of simple and it will illustrate then how much the world's changing when you move to lithium and the different products. So, essentially there's the chemical manufacturing component. It'll vary slightly between lead and lithium. It'll go into, cells for lithium, but into acid for lead, goes off to be manufactured, moves off to the OEMs, so your car companies or wherever it's going. At the end of life, the batteries will quite often come back through the sales distribution channel, and that will kind of be the first point in the end of life management chain. It might move through to scrap and collection and consolidation type sites. And then it'll move through up the top to recovering the critical minerals or the lead or other elements from those batteries so it can start the process all over again. That circle, when you think about your car battery, has been exactly that. A circle, really nice and neat, and everything just sort of moves around all the time, including for lead acid batteries, the plastics. Quite often they'll be recycled as well. What we're seeing with lithium, and again, it depends on the product, is that supply chain or that battery value chain's becoming much more integrated. So, particularly on the energy storage and the EV side, you will have heard of another number of companies either buying battery recyclers, forming partnerships or collaborations with battery recyclers as they look to secure the supply chain for critical minerals and the other products in those batteries. Recycled content requirements in jurisdictions like the European Stewart, India does it, China's doing it, some parts of the US require recycled content, is also driving that much more integrated supply chain. And that's really clear for EVs and energy storage and some of the bigger format batteries. Where that supply chain becomes much murky, or not murkier, but more complicated, is, small batteries or embedded batteries. So that might be batteries in toys or electronics, or there's a whole raft of stuff, right? So anything without a cord, you can now see cordless pool cleaners, cordless vitamizers, all that sort of stuff will have a battery in it. That's the parts that's becoming, it's difficult to collect when you think there's 20 odd million households across Australia. How do you get all those goods back in? And then the other challenge with embedded batteries or products with embedded batteries is there's all the rest of the product that needs to be recycled and managed, not just the battery. And it's those products, in particularly in that consumer space, e-bikes is kind of in that space as well. They're the ones that are causing all the fires in waste facilities. You would have no doubt maybe heard about reports in garbage trucks, that sort of thing. As I said, there's been a few household fires from incorrect charging. That's the big challenging space. Thinking about that reverse logistics chain and how do you manage that? So the Environment Ministers meeting, well, the Environment Ministers in June acknowledged the problem that batteries are causing in the waste sector. And we're talking like several fires a day, right, across Australia. It's a massive challenge, huge danger to people in the waste sector. And they've asked officials to go away and develop a draft regulatory impact statement on options for mandatory producer responsibility in the battery space. And this December, they're due to look at that draft regulatory impact statement as to what can be done. Now, we currently have a voluntary scheme in place, but that's just for loose batteries up to 5 kilos. And many of you may be familiar with dropping off your batteries at Coles or Woolies or Audis or Bunnings or those sort of facilities. But that's a voluntary scheme. So there's a few challenges with that in that not everyone's participating. And it's costly to run those sort of logistics network when you're trying to get batteries back from every household in Australia and small business. And, you know, the challenges of distance in Australia are really significant. The statement out of the Ministerial Councils has talked about all batteries. However, it is widely recognised in speaking to the jurisdictions that, you know, there's different things happening in different parts of that battery value chain, and what all batteries will mean should ministers decide to do anything is, you know, there's a lot of work to go in this space as to what will happen. You know, the meeting in December is only looking at a draft statement. So whether they make any decisions at that point in time or whether they put something out for consultation on the kinds of options that could be considered in this space, and then also who's scooped up. I think there's a lot of work to go in this space. A couple of jurisdictions, particularly New South Wales, are keen to move quickly in looking at battery recycling and mandating it. But again, exactly what that means and the level of detail around that has yet to be determined. New South Wales has been very strong in focusing particularly on the challenging areas and the areas with greatest risks. So that's micro mobility devices, plus some of the products that are coming, you know, household type products. There was a fire recently in New South Wales where my understanding of the details is a family bought some remote toys, remote control cars in the morning, charged them up, went out to do the shopping, came back and the house had burnt down. So it's looking at those, really targeting those sectors where there's product quality issues and there's known to be product quality problems and what should be done. New South Wales recently announced that it's going to put standards on batteries for e-bikes. And they also this week announced a coroner's inquiry. There was unfortunately, I think 2 deaths earlier this year or late last year that I understand involved, I think, a micromobility device. And then, of course, there was this recent incident with the house fire. New South Wales Fire and Rescue has really great stats that published on their website about the increase in lithium battery fires and the causes and what's been happening. And so I think the focus will be on, you know, not trying to cover the universe. It'll be really looking at those challenging areas and minimising the risks. They've also got the Insurance Council of Australia as part of their stakeholder group. So everyone's thinking about this very clearly in that space. And then the question will be, if you're not going to continue with a voluntary framework, what does a mandatory framework look like? And there's generally 2 models, which to my mind, in terms of outcomes, depending on how you develop those schemes, really don't have much difference. You know, the key is going to be, firstly, if you're moving to anything from voluntary, it's going to become mandatory. So you've already impacted businesses quite a lot. The question will be which businesses at this point in time. And then the next step around where you've made it mandatory, where do you go from here? So there's two options. One's kind of a flexible type approach where people can choose to join a formal scheme or run their own arrangements, or you just have one kind of super scheme. I think the recycling sector at the moment of the view that flexibility is going to be the key in such a complicated, not one size fits all market. I mean, we're not talking about standardized cans like aluminium cans here or plastic bottles, which will only go up to a couple of litres in size potentially. You know, batteries can range from anything from less than a kilo to, you know, tons. So some of those big grid scale batteries can be up to 60 tons. You know, very different solutions, very different reverse logistics routes in trying to solve those challenges. Very different levels of sophistication in the players who are handling and managing those types of systems. The other advantage that's probably seen about a kind of a flexible model at the moment is speed. And speed and timeliness is kind of really of the essence here, particularly if you're trying to target that sector where there's smaller batteries that are causing the fires in the waste sector. And I've seen some of the footage of those fires. It'd be pretty scary working in that type of environment at the moment, where you just don't know what's going to come shooting out of a waste pile when you crush that battery. And you know, there's plenty of footage online where you can see garbage trucks that have caught fire or dumped their loads, which is not convenient for anyone. So yeah, we're watching very closely this space in December. Obviously, ideally, great if all jurisdictions decide to do the same thing at the same time. We're pragmatic. We know everybody's at different stages in their policy development space. You know, if one or two jurisdictions decide to go faster than the others, so be it. I mean, there's great precedent for that in the national electricity market. And, you know, that eventually largely came down to one market as well. So, you know, that's kind of what we're looking towards in December as to where to from here in terms of mandatory management of end-of-life batteries. I will also note, and it not going to apply to the small side, which is probably why I haven't talked about it so much, there is also a lot of work going on in reuse, repurposing of batteries, particularly around those EV batteries. That's probably a whole nother topic of discussion, Marianne, that I haven't kind of got into today, but I wouldn't want people to think we were just driving the recycling solution. You know, I think people are very cognizant about reuse and repurpose as much as you can. So clearly in the battery space, it needs to be, you know, safety is the number one priority and driver in all of this. And then it's how do you get sustainable outcomes on top of that. And I just noticed there's a question about batteries. Do you want me to deal with that now?
I think so. I think that would be great. So thanks, Anne-Marie, from DQ. So the question is, at the household level, how variable is, say, a quarterly bin collection for small lithium batteries? And I assume that's from I don't know if it's from a chemistry perspective or from a safety perspective, but I think they're probably linked as well.
So thanks for that question, Anne-Marie. Unfortunately, there's no ideal solution in this space. So we kind of always look to three things. As I said, safety's an absolutely critical sport. Cost is another one, convenience, and then, I mean, sustainability kind of falls out of this with recycling, because once the batteries actually get to the recycler, so that last point in the chain, they've got really high materials recovery rates, right, because of the products and the elements in there. So when you look at household battery collection, safety's the critical thing. So there's safety around kids and button batteries. So you're making sure they don't obviously swallow them if you've taken them out of products. And there's safety around fire risks, which is still very much a work in progress. But the general view is the faster you can get the batteries out of the household. Now, particularly if they're damaged batteries, you don't want them sitting around, right? This is not like a can. A can's not going to have any fire risks, right? You can hold the cans for ages. So there's a lot of debate at the moment around whether, you know, you could have like a container deposit scheme for batteries, so pay people to bring them back. Whether you can do something like this. I know a couple of the UK councils are looking at doing battery collection with your garbage collection on a regular basis. Just, you know, everyone's got the same challenges around fires. The flip side of all of that is safety, particularly in a country like if you do something like the UK model in Australia, you know, batteries having the batteries out on a hot sunny day in Australia waiting for garbage collection or out the back somewhere is not a great idea for those that are familiar with battery chemistries. The other key concern with both the container deposit and the roadside or curbside garbage collection is how do you do that safely so that you do minimize those, you don't have those fire risks and you don't have the risks of kids getting hold of the batteries. So I'd say at the moment everything's being explored because there is no ideal solution. Now, clearly the B-cycle scheme has been a great step forward in helping households collect and consolidate batteries, and that's fine for smaller batteries. But I can't see, you start looking at camping or caravan batteries, you start getting batteries that are 10 or 20 kilos. I just can't, what sort of site do you need for those to be safely dropped off at, which might not be a retail shopping type site. It might be like a specialist site. And particularly once you start getting larger volumes. So if you have 5 20 kilo batteries, you're pretty quickly up to 100 kilos. And so the safety risks need to be managed with that. So all these suggestions are being looked at because it's that crux bit which I described in that diagram. How do you collect the batteries at end of life? So convenience is really important, right? Households need something that's not too hard. But again, you've got to tick that safety and cost box.
Yeah, a lot of different competing elements to balance up there. Thank you so much, Katharine. That was a fantastic and really informative presentation. Very much appreciated. So let's move on now to Laura Jones. We're going to stand back a bit and we're going to actually, this is looking at through a policy implementation lens, and I think this is something that I think is really interesting because Laura Jones, as the co-founder of the Circular PV Alliance, has learnings, I believe, from quite a grassroots perspective with an organisation that has grown to something that's national. And I think that there are transferable policy learnings. So Laura Jones is an experienced innovator, engineer, researcher and leader in the sustainability and in renewable energy. As I mentioned, she's co-founder of the Circular PV Alliance, where she promotes sustainable practices in the photovoltaic industry. Laura's multidisciplinary expertise spans engineering and social science, allowing her to tackle complex challenges with innovative solutions. She's worked in transmission and distribution network planning roles, as well as the connection of large-scale renewable generators. Additionally, Laura has extensive experience in participatory design processes with consumers. Her research focuses on distributed energy, circular economy practices in solar energy and just transition. So Laura's topic is insights from circular PV for household battery recycling, best practices from solar PV sector, learnings that are applicable to battery recycling, focusing on sustainable life cycle management and circular economy approaches. Thanks, Laura.
Thank you, Varian. Those intros are always like, oh, that's what I was thinking when I wrote the bio of my own, what I said about myself. Thank you for the introduction. Speaks very highly of me. I'm nowhere near as capable as I said that I was when I wrote the bio. I'd like to start with an acknowledgement of country as well. I'm here on the lands of the Muwinina people here in Nipaluna, which is otherwise known as Hobart in Tasmania. I think sometimes when we're doing acknowledgement of country, it's easy to get a little formulaic and essentially say the same words and replace it with the traditional owners of the land, which you're on at the moment. I think these things are often best when they can come a little bit from the heart. And perhaps for this one here, what I've tried to do was reflect a little bit on why am I in the circular economy space and how does that relate to the perspectives of First Nations people. I'll admit the word circular economy grates a little bit on me. Mostly the word economy, because it implies that we are doing all of this work that we're doing because we might make money. And I guess the corollary for that is that we might not do it if we don't make money. I try to see things a little different to that. Whenever we make anything, we take material from the earth. It's kind of like we're taking a little piece of our house and using it to make something that we think might be useful to us in some way. I think that when we do that, the compact we sign with the earth is to make that material count as much as possible, to use it in the best way that we possibly can, because it is, after all, a piece of our house. One of my main inspirations for thinking about that actually came from this book. It was a book that I read a little while ago. This is a series of books called the First Knowledges series. I strongly recommend people have a read if they want to, or if they'd like to. This particular one was about design and First Nations perspectives on design. There's a couple of things they said in there that were quite, I guess, helped me broaden my thinking a little bit in this space. And one of them was the word design from a First Nations perspective is what you'd say is a verb rather than a noun. So we might think of something like a solar panel or a battery as having a design, while from a First Nations perspective, it's a thing that you do. And the product is as much a product of its journey as it is of what it ends up at the end. So, for example, if you wanted to make a woomera, you would have to go to the tree, you'd have to talk to the spirits of the tree and get permission to use the wood before you could use it. And then the way that you made it kind of is part of what it is. And what that did was it gave very different connection to the things that you built. It meant that you thought about them and were connected to them in a very different way to perhaps the way that we traditionally have in Western society. So I would like to acknowledge the traditional custodians of the land, and I'd like to reflect on the fact that we are, in this webinar here, beginning to think about things in ways that First Nations people in Australia thought about for thousands of years before white colonisers came and displaced First Nations people from the land. I'd like to acknowledge that I am on Muinina land here in Nipaluna, and the Palawa people are the custodians due to genocide committed by the white colonisers. And I'd like to acknowledge elders past, present and emerging. Who am I? I'm Laura, as Darian introduced. I'm one of the 4 co-founders of Circular PV Alliance, who's a not-for-profit organisation that started in 2021. It was started, I call it a LinkedIn conversation that got out of hand. It's essentially someone made a fateful LinkedIn post where they showed these pictures of solar panels at a tip and said, surely we can do better than this. And 4 of us were like, maybe we can do better than that. So we started Circular PV Alliance as a way to try to help advocate for circular economy for PV, because we didn't want the PV boom in Australia to become a waste boom in the future as those solar panels leave their first use. We're a not-for-profit, we're an industry body. For me, Circular PV Alliance is the thing I do to give back to the world. I do this because I want to try to make the world a better place, and want to put some work into doing that without necessarily getting paid. I have a day job at the Australian National University in a program called ANU Centre for Energy Systems. This is a new name. Up until a few weeks ago, we were called the Battery Storage and Grid Integration Program, where we merged with the ABRI 100 group, looking at 100% renewable energy systems. My degree is engineering. The work I do these days kind of spans engineering and social science, which kind of, I think, gives some interesting perspectives, which I kind of enjoy sharing from time to time. If you, from our point of view, from Circular PV Alliance point of view, you can hear a little bit more about what we think circular economy for PV looks like in these reports. You can scan that QR code to get to the reports if you want to, or you can go to Circular PV Alliance website, circularpv.com.au, or just Google search Circular PV Alliance and it will come up. These are a couple of reports we did to understand a bit about what circular economy for PV was like in Australia, and to try to propose things that you might do to enhance it. This is a battery webinar though, and I'm talking an awful lot about PV. When I speak to people about PV circular economy, there are 2 questions that almost always come up. One of them is, what about wind generators? The other one is, what about batteries? So these 2 technologies are connected together in that they're often thought about as key parts of the energy transition. They're often installed in the same physical location, and they're kind of connected to each other in a technological sense. In this presentation, I'm going to focus on things like home energy storage systems for the most part, because they're the ones that are most commonly in connection with PV. Katharine ably described some of the factors relating to other kinds of batteries, and I'm not going to try talking about them because I'll probably get it wrong. We have actually been working with ABRI for a very long time. Basically, since we founded, Katharine was one of our very early supporters who helped us a lot in our journey to kind of get to where we are today. So we have a reciprocal membership with ABRI and value ABRI highly as one of our community of members. So we're here today to talk about household battery producer responsibility. I'm the second person to talk about this today. So I'm going to kind of very briefly touch on what, from my point of view, producer responsibility is and what it looks like, and then talk a little bit more about some of the factors and important things to think about as I see it. So here is an extremely simplified life cycle of a battery. Nowhere near as detailed as the one that Katharine showed. Essentially what you do is you make it, then you use it for a bit, and then you do something with it once you are not using it anymore. This is kind of like a bit of a life cycle. If we say, what does an extended producer responsibility scheme do? It makes manufacturers responsible for all of the steps inside the red. So the extended bit of the producer responsibility is you're extending the responsibility to end of life as well. You're saying, dear manufacturer, you are responsible for making this, therefore you're responsible for ensuring that the right things happen to it at the end of its life. This is all supposed to align with the concept of circular economy. This is a common framework that is used to describe the circular economy. It's from the Ellen MacArthur Foundation, who is a foundation who are, I guess, worldwide one of the leaders in thinking on the concept of circular economy. It's called the butterfly diagram. And you'll see this quoted quite a lot when people think of circular economy. Essentially what it does is it shows these concentric circles that describe different ways you can think about circular economy. The blue side is when you're thinking about technology or things that you've built. The green side is when you're talking about food and things that you eat. And the theory is that the smaller the loop, the less impactful that loop is on the world. So if you have a thing, keeping it in use as long as you can is the best thing you can do because it keeps remaining useful. So for a PV panel or a battery, if it works, keeping it in service for as long as possible is the best thing you can do. If you don't have a need for it anymore, maybe you can share it with someone. Maybe it's a thing that you don't need all the time and you can share it with others. You're unlikely to do that with a rooftop PV system because they're kind of hard to move, but maybe for kinds of batteries, that's a thing you could think about. If you don't have a use for it anymore, so for example, say you are replacing your roof and you don't want a PV system on there anymore, or you're doing something and you don't want the battery anymore, if you can reuse that, that is the best thing you can do if you don't have a use for it yourself anymore. That's keeping the device doing what it was designed to do because it still works. If that doesn't work and it's broken, you can fix it. And if you can, that's usually less impactful than anything else. If a device is broken and you can't fix it, then you can recycle it. For PV, at least, recycling a PV panel emits about 10% as much carbon as making it does, which means that if you recycle a PV panel and turn it back to raw materials, by the time it's got back to raw materials, it's emitted about 10% of the carbon that was used to make the solar panel. So you can see that there is an environmental impact from recycling. And if you can avoid needing to recycle, that's a better thing from an environmental point of view. For PV, at least, extended producer responsibility schemes have been discussed in Australia. This was a proposal that was put forward by the federal government about a year ago now that would have implemented an extended producer responsibility scheme for rooftop PV, so solar systems below, I think it was 100 kilowatts. This particular one here explicitly did not include reuse for PV. What was particularly interesting was they quoted us and said that we said that reuse was hard. We did say that there were barriers to reuse, but we also said that there were things that you can do that can remove those barriers. So we would have very much preferred had they proposed things that would have removed some of these barriers and made reuse more possible. So we wrote a submission that said that too. Hopefully, if they continue to progress this, reuse will become more of a thing. Because if you only focus on recycling, it kind of inverts the waste hierarchy. A good example of this, Smart Energy Council and My Second Life Solar are doing a pilot in Queensland at the moment where they're and also PV Lab are doing a pilot at the moment in Queensland where they're testing a lot of PV panels that are currently at a recycler to see how many of them are suitable for testing. Now, I don't think I have any results from that particular trial yet, but I do have some people have told me some of the findings from earlier tests where they found that 80% of PV panels at recyclers work. So that essentially means that 80% of the panels that are currently being ground up and turned into something else could be reused somewhere else, if we could reuse them. So this raises the question of what is a good circular economy for household renewable energy technology, focusing on home battery systems and solar PV. I kind of draw it like this. I broadly split it into 3 main phases. First is making things. Now, the important thing is that if you're committed to circular economy, it kind of implies when you make things, you use recycled content if you can get it in making it. A good example was Katharine talked about lead acid batteries being quite recyclable. They are quite recyclable, and I know, as Katharine said, a lot of the recyclers are owned by manufacturers, which means a lead acid battery you buy may well be pretty much 100% recycled. That's a good example of what we mean by circular economy. Old batteries are used to make new batteries. Lithium, as Katharine said, as far as I understand, is less recyclable. PV recycling technology is quite nascent at the moment. It is hard to recycle a PV panel, in part because it's designed to be bolted for a roof for 30 years, which means you kind of have to connect everything really firmly, otherwise it would fall apart. But that also makes it really hard to recycle. Most of the recycling that's done at the moment does not create raw materials that can be used to make a new solar panel. Using things, there are circular economy implications too. One key example of that is repair. So there are things you can do in solar panels to repair them when they break. An example of this is this picture here. This is a PV panel that was repaired by PV Lab recently using a backsheet repair material, which you can see on the back of the PV panel there. So the backsheet is the plastic layer on the back of a PV panel that keeps water from contacting the cells inside. When they fail, essentially you'll get a PV system that turns off every time it rains. But there are materials you can buy that let you repair it. So this is a project that we're doing with PV Lab that was supported by the ACT government in their Renewable Energy Innovation Fund. About to install a heap of these panels on a test solar system. So maybe this time next year, if there's no one of these, I can tell you how it went and how great those repaired PV panels are at continuing to produce electricity. But this is just a real example of what repair might look like. So you have a solar system at the moment and it fails because of a backsheet failure. What will probably happen is that system gets replaced, but you can repair it. You can keep it in service if these kinds of approaches are more available. End of life is a bit that we focus on quite a bit. We focus a lot on recycling. I kind of frame recycling as the worst good thing you can do. It's good, but there are other better things that you can do. One of the other things that's interesting as well, and as I said, at the moment you can't recycle a PV panel into raw materials that are the same as a new solar panel, so you can't use an old solar panel to make a new one. The word recycling is a word you might say there's a lot of interpretive flexibility about. Different people use the word to mean different things. So for example, if you take a solar panel, grind it up and use it as an aggregate in concrete, is that recycling? Sometimes that happens, sometimes it doesn't, which means if you're talking to recyclers, it's good to try to unpick what recycling means for that particular organisation. But what might this mean for households? Because this is household recycling we're talking about today. Now, this is a project Varian will remember really, really well. This is actually the project which I met Varian on. This is a battery trial we did on Bruny Island, where we helped 34 customers on Bruny Island install some batteries. I worked at Tas Networks at the time, which was the Tasmanian Transmission and Distribution Company. So I got very, very in touch with solar installers. So did Varian and the rest of the social science team. And one of the things that we found was the importance of solar installers at helping the participants of the trial understand what was going on, help them with the maintenance of their system and the installation and the operation. In fact, the systems that were installed were largely a fingerprint of the installer, not specifically what the customer might have necessarily asked for. So what this showed was the importance that solar installers have in this circular economy, because who's the ones who needs to enact the actions? Probably people like solar installers. So clearly they're important as the interface between the householder and the circular economy. What are we asking them to do? Well, if you're asking people to recycle things, you're basically asking them to send it off to the recycler. If reuse is a thing that you'd like to do, you'd probably prefer they didn't smash it while they're taking it off. But there are other things too. For example, testing for reuse. A good example of this is Gumtree. Lots of recyclers put solar panels that otherwise work that they've taken off of a person's roof onto Gumtree. And people like grey nomads buy them and put them on their mobile homes and then use them to supply energy for their homes while they're traveling. That's an example of reuse. Reinstallation is very, very hard to get an installer to install a second life PV array. Most of them don't really want to do it because they're not quite sure about the legalities and the risks. This is a good example of where regulation can help to make it clear that you can do these kinds of things. And I would assume that second life batteries will have similar kinds of issues, because what it is it's people are a little bit unsure about the quality and the legality of doing something. They just generally won't do it. And repair. What kinds of repair do installers need to do? So my thought to leave this presentation on is, who are the intermediaries that make this system work, and how can we upskill them to make the circular economy work better? Thank you very much for listening to me, and hopefully this leads into the next presentation well.
I think I could just listen to you all day, Laura. Just love the way you frame things and talk about stuff. Really fascinating, your focus there on the intermediaries. And of course, you know, solar installers are, you know, the interface from a policy perspective. They are the interface between consumers, at least at that initial stage of installing. But as you kind of mentioned, that kind of the stewardship and how it would, you know, there needs to be that end of life, which obviously would involve people being trained, those intermediaries, you know, battery installers, solar installers, you know, having some sense of stewardship over that process, whether they're, you know, they own the recycling stations as mentioned. But there's so many different aspects to that. Yes, it's very, very complex. There are some barriers, but a lot of options. And of course, you know, piloting is one really interesting area to look at, that in an emergent area is actually really important, which I think leads in really, really well to what Yasser, as a researcher in this space, will be talking on. There is one question in the chat, but it's actually on Katharine's chat. So I'm thinking, or discussion. So I'm thinking we might save the other questions for the Q&A at the end. So we'll just move on to Yasser. So Dr. Yasser Arafat is a chemical engineer with research interests spanning the entire life cycle of batteries, from upstream resource recovery for batteries to midstream battery development, for example, lithium-ion batteries and metal-to-air batteries, as well as downstream initiatives such as battery recycling. He possesses substantial knowledge and hands-on experience in fabricating functional battery materials and resources recovery. Yasser's work is known for its comprehensiveness and impact, and he's significantly contributed to various industrial projects, and currently is involved with the CRC project titled Addressing Electric Vehicle Battery Repurposing Challenges. So I'd refer to, there's some recent interviews, links to media on YES's research, as well as to the work that Laura and team have done too, which is in the pre-reading materials which have been sent out. So today, YESA will be talking to the need for battery recycling, carbon footprints, and the future of battery recycling. So his insights focus on repurposing of batteries, critical minerals, building a sustainable recycling ecosystem for lithium and other battery materials in Australia. So thank you so much, Yasser.
Thank you, Ariane. And good morning, everyone, and good morning, the people in WA, and good afternoon, rest of the people. And thank you for joining today's webinar. So today we'll be exploring the opportunities and challenges surrounding the lithium-ion batteries recycling. So first of all, we need to find that what's the role of lithium-ion batteries in energy transition. So lithium-ion batteries play a crucial role in energy transition, supporting technologies like EVs, solar storage, and wind power systems. In fact, they are at the heart of the global push to meet the Paris Agreement and UN Sustainable Development Goals. So, but these batteries are causing environment challenge. So it's just like solving a problem, creating another. So when lithium-ion batteries reach the end of their life, they can't simply be treated as regular waste. So improper disposal, whether through stockpiling, landfilling, or incineration, poses significant risk. Currently in Australia, we generate around 3,000 tons of lithium-ion battery waste every year. And that number is projected to rise to 137,000 tons by 2035. That's a staggering increase. So, but why is this a problem? Let's break it down. If we stockpile the batteries, they cause the fire hazard. How? Actually, the material inside the lithium-ion batteries are highly flammable, which makes them a fire risk. In Australia, we see over 12,000 fire incidents annually related to the batteries. This waste could contribute to a growing environmental concern. In case of landfilling, they pose environmental impact because, as I said, that they contain the materials which are flammable as well as toxic. And when the batteries are improperly disposed of in landfills, harmful chemicals such as nickel, cobalt, and lithium can leak into the environment, contaminating water and soil. So this causes serious health risks like respiratory diseases, cancer, and cardiac arrest. So when we consider the fire hazard, health, and environmental concern, it sounds that end of life of batteries are a liability. No, actually they are not liability. They present a major economic opportunity. How? So inside the battery, there are critical minerals such as lithium, nickel, cobalt, and graphite, all of which are high demand for the production of renewable energy systems and electric vehicles. For instance, in an electric vehicle battery pack, there is around 6 kg of lithium, 35 kg of graphite, 2 kg of cobalt, 12 kg of nickel, and 12 kg of manganese. So if we introduce them back into the production cycle, we can reduce waste and create an industry worth $3 billion. So when I was discussing these points, so it sounds that recycling resembles with the mining. Yeah, it's true. Because in case of recycling and mining has some similarities because batteries are also called overground mines and recycling is called urban mining. So how a recycling battery is more sustainable option compared to mining. So here we'll discuss why. So when we mine the virgin materials like lithium, cobalt, and nickel, we contribute to carbon emissions, habitat destruction, and resource depletion. In contrast, recycling offers a cleaner and more efficient alternative. In fact, recycling lithium-ion batteries can dramatically reduce the carbon footprint of producing new batteries. So besides recycling, another key strategy is repurposing. Repurposing of the batteries is actually the second life of the batteries. When lithium-ion batteries are no longer useful for electric vehicles, can still serve another life in stationary energy storage for homes and businesses. For example, a battery that is no longer efficient for driving can be repurposed to power a solar energy system. This extends the battery's life by another 5 to 10 years, contributing even further to circular economy. So the question arises that what's the status of battery recycling in Australia? Unfortunately, the recycling rate of lithium-ion batteries in Australia is still critically low, at around 10%. And top of that, recovered black mass is being shipped overseas, where other economies are capitalizing on our resources. So black mass, maybe most of the people knowing, but maybe some people don't know. Actually, in case of recycling, there are two parts, recycling and refining. After recycling, the end product is the black mass, and the subsequent step is the refining, where we segregate these materials like nickel, cobalt, graphite, and lithium. So even we people are not refining, although some people have already started, but still the volume is low, and we are sending this black mass to overseas for the refining. In contrast, Europe recycles around 60% of its lithium-ion batteries and is set to ban the export of black mass. Meanwhile, China dominates the global market, controlling 60% of global recycling capacity. So what we can do to enhance this 10% recycling rate to higher. So to catch up, Australia need to take urgent action. Here's what we need to do. Firstly, we need to invest in the recycling infrastructure. We need large-scale, cutting-edge recycling facilities to process the growing volume of the used lithium-ion batteries. The government could incentivize the recycler with tax breaks, grants, and subsidies. We also need to enhance our collection rate. And there is a great need for the collaboration between the different stakeholders. A strong recycling ecosystem requires collaboration between industries, governments, and research institutions. So, and we also need to invest more in the research and development. We need continual research and development into more efficient, cost-effective, and environmentally friendly recycling technologies. So in conclusion, a circular economy for lithium-ion batteries offer a path to reduce the environmental impacts and keep valuable materials in circulation. By focusing on recycling, repurposing, and collaboration, we can not only reduce waste, but also lower carbon emissions and create new economic opportunities. Thank you for your time. Let's work together to ensure that lithium-ion batteries contribute to a sustainable circular economy for next generations.
What a fantastic presentation. Thanks so much. Yes, sir. Really interesting point there about, I'm sure Katharine would agree, how black mass is just such a critical topic. And I always find it really interesting when you know, you're posed with a challenge or a barrier, and yet, you know, there is a way to say, look, these are actually opportunities. So looking at waste, you know, if you were to present to government and say, look, you know, this is an opportunity, looking at waste as a different type of mining, it's you know, the efficiencies and economies there that would speak to people in government. So that was very, very interesting. Also, I think with the the leaching of some of those heavy metals certainly reminded me of a time working for BHP, doing groundwater modelling in one of their assets and looking at, materials like that leach into groundwater. So I think, gone are the days where, people would be, hopefully gone are the days where people are throwing their batteries into the bin, and at least now there is some movement, at least at the municipal scale, where we do have these drop-off centres for batteries and things like that 5-10 years ago were nowhere near as accessible. A lot of really interesting points there. So let's open it up to the floor, and I think obviously the panelists are welcome to ask questions of each other as well. I might just kick off and just ask Katharine if she's happy to talk about it. I think she may well be, about some of the kind of key points from a policy perspective that you'd be hoping to see to come out of the Environment Ministers meeting in December.
I mean, we're clearly obviously looking to whether they're going to mandate, or I don't know if there'll be a strong statement around that, move towards mandating producer responsibility and then what we look like. But as the other speakers have alluded to, there's a number of parts to this chain. So that's really looking at the collection and the responsibility part of the challenges. There's clearly also safety around storage and handling. There has been a lot of funding from a number of governments towards support for expanding recycling facilities, which is great to see. Black mass, as Jess has referred to, is probably the sort of next cab off the rank. It has been exported overseas because the volumes are just too small here at the moment to have any financial viability in investing in that sort of capital. But you'd hopefully see down the track that that's what we move towards doing. And I also think commitments under the Basel Convention will push things that way. Australia has to process its hazardous waste onshore where possible to do so. So, I think the Environment Minister, they've got a big portfolio of things to focus on, right? I think their key question will be around where to around here around the smaller batteries and the electronic, e-waste. And I use e-waste in the very broadest of terms here, right? Not just electronic. It's everything you've got in your household with a battery in it that needs recycling, how to manage those products safely and get them out of the waste stream.
We've got a question in the chat, and it's Johannes Paul Lehman. I'm not sure if he's still online, but I'll just read that out. So it's mainland Chinese focus. Johan's in the process of moving from his lives and works in China, is about to be moved to Australia. So question to Katharine, could you imagine a battery life cycle, battery coding and tracking or tracking standards like the mainland Chinese GBT, and the numbers are there, 2017. Oh, here we go. There's Johan's there.
I can also quickly allude to those, just to give you a little bit of more background. So back in 2018, I was the key project lead at Porsche in China for those standards. And basically, they established a whole traceability all the way from manufacturing, selling, importation, after-sales service, even to second life services. And basically what they had on cell level, module level, and pack level was that you had a specific 20 to 24-digit code. And then it all was tracked basically through a database, so that at every given moment, the government, but also you as a manufacturer, always knew where the battery is, and then where in the end it ended up, let's say in the second life or even recycling use cases. And then what actually happened, that was the second standard, was that they introduced that also for small electronics devices in the year 2022. So again, to keep the resources in the country, the black mass, we said it before, how much capacity they have on the recycling bit, but that was basically to strengthen the whole transparency. And that's why this question, can you imagine that something similar had to happen in Australia? Or is it really all voluntarily, and then they maybe do it or maybe don't, but still sometimes we have some missing links in the end?
Definitely, right. It'll come. It'll probably come, where Australia's a very small market, right, in this place. I think it'll be driven a lot by what happens internationally, and whether that's European, like the European battery passport, or standards out of China, or some sort of combination. We're advocating very hard that whatever it is, it's an existing scheme, like one of those. We don't want to reinvent the wheel. And, you just look at the EV market here, right? All those cars are coming out of Europe, China, or the US. So we'll probably more likely pick up what's happening there. And I know a number of the recyclers and one of the companies here that's doing battery reuse and remanufacturing is already developing systems to fit in with that sort of track and trace technology. There's another company that's developing track and trace because they do it out of the mining sector. So that, again, it's tracking individual critical minerals or other metals, again, around this social and corporate responsibility standards. So yes, it'll come. As to when it gets mandated here, like mandatory tracking and tracing, that's less clear to me. The focus at the moment really is those small batteries, and the batteries that, e-bikes, right, is the biggest challenge fire risk wise. And that's kind of what's driving the policy agenda here at the moment. But I expect that, over the next few years, you'll definitely see changes in that space. And I know a number of the OEMs, both energy storage and EVs, reach out to us about recycling here. And they're clearly looking at that as well. So yeah, it might be a little bit less formal the next few years, but I imagine it will become more formal down the track.
Do we have anybody else that's got, Laura, go ahead.
Yeah, sorry. Yeah, I was just actually reminding from a PV point of view, I know there were some projects in Europe that did some work on this kind of thing, like working out how you can attach like RFID tags to solar panels in a way that they still work after a number of years out in the sun and rain. I think the Circular Solar project have got some reports on that. One of the things, I guess, as well is when you're talking about recycling, knowing what something's made out of is really important, because different processes apply to different kinds of manufacturing, and it's quite hard to tell sometimes from looking at a device what it's exactly made out of. So there's a lot of reasons why it's really good to have that tracking and tracing kind of thing in place.
Yeah, here is the interesting point, Johannes, because the major bottleneck in case of repurposing of the batteries is this one, the lack of data, because we are not aware of the present state of the battery, because after the end of life of the batteries from the EVs, because the batteries can be repurposed, but still as a result of lack of data, we cannot find the remaining capacity of the batteries. And that's why we have to do some diagnostic techniques and prognostic techniques, and still we are not sure. So if the manufacturer provide this RF tagging or the track and trace system, we can identify the remaining capacity of the batteries, and they can be more useful for the repurposing purpose, whether it be a solar or wind or some UPS. So it may be useful. Yeah, good point.
Yeah, it's interesting. Sorry.
Yeah, I was going to make one comment. Like, I know most people would realise with solar panels, when the manufacturer has a code on them, which is mainly if they test them before they leave the factory. So when you receive a pallet of panels, you actually receive a spreadsheet which lists every panel that you've got. But when looking at recycling, I actually raised with one of the manufacturers, how they actually tracked, the actual numbers. And they said, well, we track them to where we sell them. Once we sell them, that's the end of it. That's our responsibility gone. We don't care. It's whoever purchases them. So I think, it'd be good if we could actually we need some sort of system where they're actually tracked from, whether it's solar panels or whether it's the batteries, where the manufacturer, when they pass that data on, there has to be some way of keeping track of down the track Like I know when we did the solar system at UQ, the original one, we had 5,004 panels. We broke them up into sections of 22 panels for research purposes. We could tell what panel was where. But if I went back, well, I know they're being replaced at present, but that was the end of the story. No one actually ever kept track of the numbers. You had the spreadsheet, they were filed, end of story. I think we need some sort of, this comes down to policy, once we actually go through into setting some sort of standards as to how we actually keep track from the circular economy, there needs to be some way of tracking where something is at any one point in time. That's something that will probably take many years to achieve, but it'd be nice to see it happen. Do we have any other questions from the floor?
Robin's put a note in the chat, tracking the panels by barcode, which is good to be able to do that. And I think actually I'd like to build a bit on Yassia's point about testing as well. One of the important things of testing is driving the cost down to the point where, because like testing it's important for people to build up the assurance that a second life product is suitable for reuse. Different kinds of tests are labor intensive in different ways or costly in different ways. And I think it's trying to get to the point where you can do the testing low cost, in a low cost enough way that it still makes sense to have that reuse happen. Yeah, I appreciate the fact that there are people, at least in PV, working on that. So yeah, and hopefully the same kinds of things are happening for batteries. I don't know.
Yeah, there's definitely testing work happening and standards, right? So National Transport Research Organisation's just been working with Infinitive down in Melbourne to at least develop a standardised more certification around process rather than a quality, performance related type one, so to speak. But all of that will come. And it's needed for, as you say, customer confidence.
Yeah, I saw this one. There was one paper that talked about this that said using the word waste to describe things that are removed from service is bad because it sets the expectation that it's not useful. Like we think of waste as not useful.
The terminology waste's really unhelpful, right?
Really,
really unhelpful.
I think I suggested midlife for as an alternative.
Yeah, and actually batteries are quite different from the PVs because of the safety concern. And when these batteries are charged, so there is a possibility of explosion even. So first one is the flammability, explosion, and toxic materials are there. So this track and trace system, barcode, some method through which we can estimate or find the remaining capacity of the batteries, it will be very helpful for this for its utilization in the future.
Yeah, absolutely.
Yeah, the biggest challenge with batteries is the logistics. Like they're quite recyclable, and yes, the materials recovery process, as Yasser referred to, can be improved. Use greener chemicals, so to speak, or less energy, but you can do it. It's the collection and logistics is really challenging because of the fire risks.
Yep. Yeah, actually, Darren made a comment about testing always uneconomic. Batch testing is a thing that we've thought about a bit, at least for PV, because obviously if you only need to test some that come in, it makes things a bit cheaper. One of the tricky things we have is because we've got so much rooftop PV in Australia, you've only got a relatively small number of devices installed in one place. In a lot of cases, like if you've got a solar farm, it's great. You can kind of reasonably estimate that all of the panels have had kind of a similar life. But if you've got a rooftop PV system of 20 panels, like there isn't that much. You can get you can test like a couple of them and that, but it's not as much gain as you would have for a large scale solar farm. So yeah, I think you kind of need to do both. Do everything you can to make the testing as cheap as you can, and then do other things like batch testing where you can to make it cheaper again. For batteries, I would expect it'll be probably more important to test them all, just because of the safety.
I don't know, right? Because at the moment, the nickel metal hydride ones from like your Priuses, it's relatively easy, right? We've got companies here that'll take 10 or about 10, makes 7 or 8 refurbished 7 or 8 ones. I mean, they sell them clearly as refurbished, not brand new, but that's quite effective and cost effective for the customers. And I'd have to check whether they're testing every battery or whether there's different processes happening there. Lithium's clearly a different challenge, right? Because of the fire risks. And there's a lot of great work coming out of Perth at the moment, looking at the development into energy, converting EVs into energy storage batteries.
Yeah, and as he was asking about the reusing, yeah, because in case of lithium-ion batteries, we have to undergo these batteries again for stringent testing, because we are not aware that it has undergone the mechanical abuse, electrical abuse, or the thermal abuse. So if we do not test this battery and reuse them, actually I'm more focusing on the batteries recovered from the EVs. So if we'll not do the testing, so we are not aware that it may have undergone some abuse condition, or it has undergone some accidents, and there is some mechanical abuse of for the batteries, because these batteries are more vulnerable. So yeah, it would be necessary to have retesting, and not only the simple testing, stringent testing we have to conduct before reusing. Otherwise, we prefer to recycle it.
Yeah. And battery, like when you reuse batteries, right, at the moment, it's really only the electric vehicle ones, because there's still a significant level of capacity in there. You're not looking at, I mean, there's some work going on in smaller, cells for smaller products, but that's going to have to be done very, given the concerns about the fire risks and all the other implications of doing that. There's also a lot of work going on to prove that that's actually a safe route to go down.
Katharine, in terms of from a safety perspective, and I'm just wondering, because I'm not aware of the specific example using the Perth case study, but just thinking about, because obviously electric vehicles are between 5 and 7 times the capacity of household batteries, and there's been talk in the past, of course, of using electric vehicle batteries that are no longer have the capacity that they did, to kind of put them together and use them as for community batteries. Is that something that you have been looking at as well, or know about? Is that linked to the Perth?
100%. So I think it's Edith Cowan University out of Perth that's been doing a whole heap of work on that. But there's commercial companies doing it as well. You'll also see, that going back to that diagram, right? There's some interesting partnerships, and this is all a research, or it's a research pilot type stage. It's not, as far as I'm aware, large scale commercial. Even some of the mining companies are looking at it, because they've got those big industrial fleets, or they'll have or they'll invest in subsidiaries or startups that are doing it. Car companies, clearly, I mean, you can look at a number of the EV car company sites here, right? And they'll say, we reuse, we repurpose, we recycle. It's kind of our committed approach. So it's definitely being worked on. The challenge, I mean, as Laura's alluded to, is really, particularly with these batteries, is going to be confirming that it's safe and the insurance implications of these sort of products.
Yeah, and I think also we've got the legal implications. You know, whenever we reuse anything, there's always going to be who accepts the warranty.
Yeah.
So I think that's where we're going to require some sort of policy intervention.
Yeah, there's a piece, we've got some work on our website, and I'd love everyone to have a look at it. We're trying to put together a list, particularly to help local industry here, of all the research work that's going on across Australia in the battery space. So that lists some of those EV projects. IOG is looking into this area heavily, again with Edith Cowan and through the iMove CRC, because, you know, clearly they've got an interest in this space. You know, normally when a card gets written off, it'd go off to scrap for sale. But with an electric vehicle battery, the financial proposition, and as Craig alluded to, the risks and a whole lot of other things clearly change. So what's the model for that in future? I think the presentation from their it's up on our website too. I might just put the link in now for everybody. They can have a look. But there is definitely work happening in this space, right? Because people are trying to work out, as we transition to EVs, what's going to change in their financial or commercial or other models, and what do they need to change or do or tweak to make that fit.
Yeah, at least for PV, there are these points where standards change, and that can be a barrier sometimes. Like I think it was 2013, or it could be 2016, where fire standards changed for PV panels, which kind of mean that panels older than that probably can't be reused to the same extent as more modern ones, just because the standards are different, even though like they may technically be the same, they just weren't tested to that standard in the past. So yeah, the insurance one's pretty important to disentangle, I think, too. There's lots of reasons why people might not want to use a reused device, and, you know, cost's only one of them.
Yeah, I think insurance is a really, really important point, because obviously that adds, you know, that's a layer of risk, and, you know, adds cost and that sort of thing as well. Yeah, so I'm just wondering if you may have any comment on what Katharine was talking about, since you are part of the iMove CRC and at ECU.
Yeah. First, I'll respond to the question Johannes has asked about the thermal propagation. He was talking about some, I guess, latest technology. The emerging technology in case of a lithium-ion battery is the solid-state lithium-ion batteries. So where we replace the liquid electrolyte with the solid ceramic one. So, but lithium is still there. The flammability is due to the lithium. So we cannot completely rule out the possibility of the thermal runaway because lithium is there. But as the liquid electrolyte, which is also based on fluorine and lithium, that one is toxic as well as the flammable. So in case of solid state batteries, that has been replaced. So the possibility will be significantly reduced, but we cannot completely rule out. So as the Varian is asking about the, our project, so our project is related to the 4R. So we get the batteries from EVs, and then we repair them, refurbish them, repurpose them, or eventually recycle them. So this project is 4R. So in this one, mostly focuses on the repurposing. So we try to get the batteries from EVs and do some diagnostic test to estimate the remaining useful life of the batteries, and also do some prognostic tests to forecast its future life. So based on this future life, we use this one in different application, be it solar panel related batteries, the stationary storage, or in some mining applications, are UPS. So that's the brief intro of our project.
Thanks, Yessa. Laura, Susie's got a quick question for you. If you're able to see that in the chat.
Yes, yeah,
From a network perspective, are there any barriers to repurposing EV batteries for community batteries? Who would own and operate them?
Yeah. So I guess, I obviously don't work for TasNetworks anymore, so I can't explicitly say what they would or wouldn't do. But I think if you can get the batteries to the appropriate standards, then, they should be able to be used the same way any other community battery is used. I think Australian experience has shown sometimes it's easier for networks to install community batteries, if nothing else, because they know how to install things, while community groups, there are some community groups who have all of the expertise you need to do all of that work, but they're not quite so common. I know in TasNetworks, in Tasmania, TasNetworks is installing a couple, right? So you probably know that better than I do. Yep.
Yeah, they've got two that they're working on that they got from some funding from the Commonwealth Government after the last election. One at Shorewell Park in Burnie and one somewhere near Howrah. I'm not sure exactly how much additional network support was needed in either of those two sites. But TasNetworks has also got some funding bids in with ARENA for some that are definitely beneficial in terms of network support. One of the issues with community batteries that I think is a bit of a sleeper problem, and we've had a bit of an exposure, is that it's great when you get a community group of half a dozen very keen, enthusiastic people who are prepared to put in a lot of time to running some of these smaller projects, and then they either lose interest or move on, or the time issues become problematic. We've had a small microgrid in Tassie that's suffered from that. It got quite a lot of funding for some additional support, and that's now got the stage where the community group that got the funding no longer includes any people who are particularly interested in it, and they've tried to get someone else to take over the running of it. And it's not been easy because it's too small to be economic. So it relied on volunteers. So it is the community battery issue is a problematic one because they're often located in the community, but not necessarily run by the community.
Yeah, there's a big difference between a community located battery and a community run battery, and maybe it's a topic for a different webinar. But the governance models and the operational models are a really, really thorny problem. If you go to the bizkip.com website, there's a community battery knowledge hub on there that talks through some of those issues as well. I assume our new ACES website also connects to it. I'm aware we've got -1 minute left, so maybe I can.
Can you put
That's right.
Put that link in the chat?
Yeah, I'll just see if I can do that in the last few minutes.
Well, we are well out of time now, but so I'll just hand over to Craig, who's just going to do a quick little wrap up for us.
Given I'm not sure whether they'll actually cut us off or whether they'll let us keep going, I suppose I'll start by thanking our speakers, because it's certainly been a very interesting and discussion. It certainly raised a number of points that I'll be following up just with some of the work that I'm doing. I think there were a few key messages that came out of it, and I think that to start with, we've got to look at, when we talk about recycling, we've got to be aware that there's not one solution. There are different technologies. They all have different supply chains, and therefore, whatever moving forward, we actually have to look to accommodate for those. Obviously, goes without saying that policy is going to play a very major part of it, and that policy in a lot of cases will be very jurisdictional. So what's being done in one state, hopefully if some states such as New South Wales are taking a lead, then we can follow. And I certainly know, as Robin's pointed out in some of the chats, we've got with the solar side, we've got the recycling project that the Smart Energy Council is running in Queensland, and it certainly had a lot of support from the Queensland government. I think similarly the circular economy, for want of, as Laura pointed out, for want of a better term, we do have to look at, with recycling, there is that recycle or reuse argument. And I know with what the Smart Energy Council are doing with solar, that is certainly part of their argument. And we're going to have a look at who is responsible for making that decision. Does it come back onto the recyclers that if they receive something, it's just not a case of dismantle it or dispose of it? Is there an obligation to actually look at whether something can be actually repurposed? And then finally, when we do actually look at recycling with batteries, they are a mine of critical minerals. The critical minerals, particularly again in Queensland, is a very, very major topical point. So we can't just with recycling, we've got to look at how we can actually reuse by breaking down the minerals that are already in that battery. And when Yasser broke down the various weights that in a typical battery, like everybody considers the lithium battery only contains lithium. There are quite a lot of other minerals in it, same as a solar panel just isn't silicon. There are a whole different lot of parts to it, and some of them can be recycled quite easily, some of them can't. So therefore, it does come back to it can be an economic question. I think we've certainly got a few issues that we can take forward, and I dare say we'll certainly summarise what's come out of today and come back with what we see are probably the next steps moving forward. So thanks everybody for attending. I'm sure, Marianne, do you have any closing comments?
That's all. Thanks so much, everybody, and thank you so much for our expert panelists for such fantastic presentations.
Okay, well, thanks everybody. Cheers.
Thank you. Thanks.
Right.